Today in Math 30-1, we're looking at topic 11.2, combinations. This is from page 528. A combination is a selection of a group of objects taken from a larger group, for which the kinds of objects selected is important, but not the order in which they're selected. Order is not important in this part. There are several ways to find the number of possible combinations. One is to use reasoning. You can use the fundamental counting principle and divide the number of ways that the objects can be arranged among themselves. For example, calculate the number of combinations of 3 digits made from the digits 1, 2, 3, 4, and 5 without repetition. The number of choices for the first digit would be 5. The number of choices for the second is, of course, 4, and for the third digit would be 3. So there'd be 5 times 4 times 3, or 60 ways to arrange 3 items from 5. However, the 3 digits can be arranged in 3 factorial ways among themselves. And in a combination, these are considered to be the same selection. So the number of combinations would be the number of permutations divided by 3 factorial, and that would be 60 divided by, well, 3 factorial is 3 times 2 times 1, which is 6. So the number of different combinations would only be 10. So the notation n choose r represents the number of combinations of n items taken r at a time. N has to be greater than or equal to r has to be greater than or equal to 0. Now, if we set n choose r, that's going to be npr divided by r factorial, which is n factorial over n minus r factorial over r factorial, or in its final form, it's going to be n factorial over n minus r factorial times r factorial. This last one is the one we're going to use. For example, let's say we wanted to have the number of ways that you can choose 3 items from 5 items. This would be written as 5 choose 3. We'd say 5 factorial divided by 5 minus 3 factorial times 3 factorial. Now 5 factorial on the top over 2 factorial times 3 factorial on the bottom. We can expand 5 factorial to be 5 times 4 times 3 factorial over 2 factorial times 3 factorial. We will cancel the 3 factorials, leaving us with 20 on the top. 2 factorial, or 2 times 1, is 2 on the bottom, and the answer will be 10. There's going to be 10 different ways to choose 3 things from 5 things. Remember, a combination is a selection of objects without regard to order. All of the 3-letter combinations of P, Q, R, and S are PQR, PQS, PRS, and QRS. Arrangements such as PQR and RPQ are considered the same combination. Okay, let's look at example 1. Combinations in the fundamental counting principle. There are 12 females and 18 males in a grade 12 class. The principal wishes to meet with a group of 5 students to discuss graduation. How many selections are possible? Well, what that means is that from these 12 plus 18, 30 students, we have to choose 5. So we have 30 choose 5. So we'd write that as 30 factorial over 30 minus 5, which is 25 factorial, times 5 factorial, which we're going to expand it out now, and 30 can be written as 30 times 29 times 28 times 27 times 26 times 25 factorial over 25 factorial times 5 factorial. Now we're going to cancel the 225 factorials. Now 5 factorial, if you expand that out, well, the top's still going to be 30 times 29 times 28 times 27 times 26. The 5 factorial is going to be 5 times 4 times 3 times 2 times 1. Now, we're going to cancel some more. Notice on the bottom I have 5 and I have a 3 and a 2. If I multiplied those together, that's 5 times 3 times 2 is 30. So I could cancel the 30 on the top with the 5 and the 4 and with the 5 and the 3 and the 2 on the bottom, never mind the 4, and that would leave me, oh, I can cancel something else. I can cancel a 4 on the bottom with, I can fit 4 into 28 on the top and leave me with 7. So now on the top I'll have 29 times 7 times 27 times 26. On the bottom I just have 1. If I multiply that out, I'm going to get 142,506 different ways we can pick 5 students from a group of 30. Part B. How many selections are possible if the group consists of 2 females and 3 males? So now I'm going to start doing them separately. So this means now for my first group, 2 females, I got to choose 2 from 12. So there's 12 choose 2 ways of selecting 2 females, and that leaves me with, I have to choose 3 males from 18, so that would be 18 choose 3 ways of selecting 3 male students, and that means that you'd have to multiply those 2 together to get the total different number of combinations. So we'll say 12 choose 2 times 18 choose 3. So now to do the little calculations, you've got 12 factorial over 10 factorial times 2 factorial times 18 factorial over 18 minus 3, or 15 factorial over 3 factorial. And that's going to be, if I expand it and simplified it, there we go. Now, if we start canceling, we can say, well, what do I got? I got a 10 factorial and a 10 factorial. Remember, 2 factorial is just 2 times 1, which is 2. So I can cancel 2 on the bottom, and I can fit 2 into 12 to make that a 6. There we go. Over on the other side, I'll cancel the 2 15 factorials. Now I'll cancel the 3 times 2 times 1. 3 factorial is the same as 6. 18 divided by 6 is 3. So now I'm ready to multiply. 6 times 11 is 66, times 3 times 17 times 16 is 816, just off the top of my head, of course, is going to equal 53,856 different ways to select a group of 2 males, 2 females, and 3 males from a group of 30 students. Part C. One of the female students is named Brooklyn. How many 5-member selections consisting of Brooklyn and 1 other female and 3 males are possible? Okay, so now we have to consider, we have Brooklyn, we have to pick 1 of 11 females that are left, and then we still have to pick 3 males from 18. So we'd say that would be 1 for Brooklyn, 11 for the other females choices, and 18 choose 3 for the males. So there we have Brooklyn, there we have 1 other female, and there we have to pick 3 boys. And when you multiply that out, 1 times 11 times 8, 16, is going to give us our answer of 8,976 different ways of selecting the group. In example 2, well, we have combinations with cases. Rihanna is writing a geography exam. The instructions say that she must answer a specific number of questions from each section. How many different selections of questions are possible if she must answer 2 of the 4 questions in Part A and 3 of the 5 questions in Part B. And then she must answer 2 of the 4 questions in Part A and at least 4 of the 5 questions in Part B. Okay, 2 different questions. Let's start with Part A. Here we have, we're going to have, first of all, for Part A, she's going to have to take 4 questions, choose 2. For Part B, she's going to have to take 5 questions, choose 3. Well, 4 choose 2 is going to be 6. 5 choose 3 is going to be 10. That means that using the fundamental counting principle, 6 times 10 will be 60 different possible choices for Section A. For B, she must now answer 2 of the 4 questions from Part A. Okay, we already know what that is. At least 4 of the 5 questions in Part B. Well, this tells me now I've got 2 cases. And case 1 is where she answers 4 questions from B, and case 2 is where we're going to get 5 questions from Part B. Now what we're going to have to do in the end is add those 2 cases together. So we're going to have 4 choose 2 times 4 choose 5. 5 choose 4, sorry. And that's going to be, first one is 6. 4 choose 5 is 5. That's 30 different choices. 4 choose 2 is, of course, 6. 5 choose 5 is simply 1. So there's only one way of doing that. So 6 times 1 is 6. So altogether, she has 30 plus 6, or 36 possible ways of answering 2 of the 4 questions from Part A and at least 4 or 5 questions from Part B.